Nice. I'm going to do a quick demonstration of what is called the Coanda effect. It's spelled C-O-A-N-D-A, and basically what it says, it talks about when a jet of fluid hits a wall or an obstruction, how it fans out and takes on the shape of that wall. And it's used a lot from what I read in like aerospace applications and things like that, but it also applies to us with the heart. And when you see it, you'll probably recognize it as something you kind of intuitively know, but you just never thought of in relation to the heart and regurgitant jets specifically. So in this demonstration, the water coming out of the faucet is going to represent the regurgitant jet coming out of the heart, and the spoon is going to represent the wall of the ventricle, or the atrium, depending on where it's coming from. So I'm going to turn on the water here, and then when I put the spoon underneath and rotate the spoon, you'll see how the water is fanning out over the edge of the spoon. So if you're looking at an ultrasound image of this, and from this particular angle, the regurgitant jet is below the edge of the spoon here, you're going to see a very thin jet, and you won't quantify it or qualify it as a very large jet with color Doppler when you see it from that angle. But if you rotate it 90 degrees, you'll notice that the jet gets much wider and would look much bigger. So from our perspective, if we were looking at an apical 4-chamber view versus an apical 2-chamber view, you would see something totally different. And that's just the point of the example, is to make sure you assess the jet from as many different angles as possible, because it really can look different and can affect your conclusions. Thank you.